Okay, since I am going to be gone for 2 days, I thought it might be beneficial to finish the notes via this video. So hopefully it works out. It's my first time trying it. I'm sure it will be riveting. We are on the bottom of page 2 of the notes. The mean of any discrete random variable is still just an average of all the possible outcomes, but each outcome is weighted by its probability. So that means an outcome that is more likely is weighted higher than an outcome that is less likely. This is kind of like how you figure out your grades for this class. Your test grades are weighted with a higher percentage than your homework grades. The formula to find the mean, or it's also called the expected value. So from now on, if you see expected value or expected number of such and such, that is the same thing as asking the mean. You can write it as E of x, or mu sub x is given by this formula. It's actually very easy. You take each x times its probability. So the first x times its probability. Then add the next x times its probability. Then add the next x times its probability, etc. This formula is given on your formula page, but it's not written like this. It's written like the second one, as you might expect, in summation form. So it's the sum of each x times its probability. So that is on your formula page. We'll test out this formula on the back page. So here, if I can get this, there we go. This is the same example from yesterday. It is the probability distribution of the number of goals scored by a randomly selected team in a randomly selected game. It says compute the mean of the random variable x and interpret its value in context. So we could write E of x, or mu sub x, and then I'm just going to take this x times its probability, plus 1 times its probability, plus 2 times its probability, plus 3 times its probability. You get the idea. So I'm going to write 0 times 0.061, plus 1 times 0.154, plus 2 times 0.228. As you might expect, even if you did all this work in your calculator, if this is a free response question, you still want to write all of this out. However, on a free response question, they probably wouldn't give you a distribution that is quite this big to write all of this out. Okay, so if you did all of that, plug it into your calculator, it should come out to 0.2851. That makes total sense because the two highest probabilities are 2 and 3. So we'd expect the mean to be near them, 2.851. You may have thought, isn't there an easier way? You might have put list 1, all your x's, list 2, all your probabilities, and then in list 3, make sure to get the blinking box. Do L1 times L2. Then you could sum that list. Sum is found under lists and then scroll over to math. It says interpret this value in context. It's actually very easy. Don't overthink it. You can just write the average number of goals scored by a randomly selected team in a randomly selected game is 2.851, or you could even say the expected number of goals is 2.851. Even though there's no possible way you could get an actual goal number of 2.851, since it's an average or expected value, it can be a decimal. The standard deviation and variance of a random variable measure how far away or how much the data is spread out. So the variance is similar to the definition of variance for a set of quantitative data, which we did in chapter 1, and the standard deviation is just the square root of the variance. So the variance, you take each x, subtract the mean, square that so it's always positive, then multiply by its probability. Then take the next x, subtract the mean, square it, then multiply by its probability, etc. This is also given to you on your formula page in summation form. Each x minus the mean squared times its probability. I'm not sure why on your formula page they give you the variance when we usually use standard deviation, so you have to know the standard deviation is the square root of the variance. The variance doesn't have a meaningful interpretation, but the standard deviation does. It's the same as we learned before. The interpretation of standard deviation is how much the values of the variables tend to vary on average away from the mean. It's still the average distance from the mean. Okay, finally we will calculate the standard deviation of this same data set. Remember, we found the mean to be 2.851. To compute the standard deviation of a probability distribution, you probably want to use your calculator for help. So if you haven't done so already, I plug in list 1, all your goals, your x's, and list 2 for your probabilities. Then remember, what I need to do is take each x minus the mean, square it, and multiply by the probability. So in list 3, get the blinking box, I'm going to take my x's, which are in list 1, subtract the mean, which we found was 2.851, square it, and multiply by our probabilities, which is in list 2. Then we could take the sum of list 3. However, that would only give us the variance, so the very last thing we want to do is take the square root of that answer. Now, I forgot to bring my calculator home, otherwise I would show you how to do that on this video, but you guys are on your own for that. There's a much easier way to get the mean and the standard deviation, which you are more than free to use. Make sure to put your x's in one list, usually list 1, and your probabilities in a second list, usually list 2, so you probably already have that done. And then you can do one variable stats, list 1, comma, list 2. Make sure your probabilities, or whatever it's weighted by, is always in list 2. It's always the second list you plug in. If you have the calculator that looks different, you'll see something that says frequency list. That is where you'll put your list 2. Then you should see X bar, and a few rows down you'll see sigma X. X bar, we know to change to mu because this will be a population. We use sigma X. There is no SX because your calculator recognizes this is a probability distribution and it involves a population. So you are more than free to use this every time to calculate the mean and standard deviation. However, if asked on a free response question, I bet you can guess, when using the calculator shortcut, still show your work how you would obtain the mean using multiplication and addition, and then actually find it using this. You don't need to do this for standard deviation. The likelihood they'd ask you to calculate standard deviation by hand on the AP test is fairly small anyway. All right, this is your assignment. You have the rest of the period to work on it individually or in a group. Also, congratulations on winning the food drive. That was awesome. Talk to you soon.